Good morning, everyone. Welcome to our sessions. My name is Kaifeng Zheng. Today, I'm here with my colleague, Wavi, to talk about TabJolt. Just a little bit about myself. I'm the test manager of the vSQL Server team here in Tableau. I have been with the company for 4 years, and this is the 4th TC I've attended.
And I'm Ravi. I'm also in vSQL Server team. I am at Tableau for about 3 years, and this is my 3rd TC. And I'm gonna show some demos, and both of us will talk.
So before I start the talk, I'm just curious. By raising your hand, how many of you guys have encountered Tableau Server administration-related challenges, such as capacity planning, server upgrade, or performance troubleshooting in your day-to-day job? Wow, almost everyone. Yeah. So hopefully, after today's talk, you'll be able to come back to your workplace and comfortably use TabJolt to solve those challenges. And you won't be looking as sad as this person when those challenges arise.
That's how I look when it goes well.
So here's the agenda for today's talk. First, we are going to introduce TabJolt. Then we are going to talk about some of the common Tableau Server administrators challenges and how you could use TabJolt to solve them. Then Wavi is going to showcase a demo for how easy it is to install, execute, and perform analysis by using TabJolt. Then he's going to walk through a case study by using a TabJolt to conduct capacity planning. The last demo he has is to use TabJolt, is to actually tweak the default configuration of TabJolt to meet your specific needs. Then I'm going to talk about what's coming in the new release of TabJolt. Finally, I'm going to share some of the best practice of performance testing we have here in Tableau. Then we are going to leave 15 minutes at the end for Q&A. So what is TabJolt? In a nutshell, TabJolt is a point and one load testing tool designed specifically for Tableau Server. It's very easy to get started with. You don't need to have any prior programming, scripting, or even load testing experience. You could just point TabJolt to one or more workbooks in your Tableau servers, and it will simulate hundreds of thousands of active users viewing and interacting Tableau Server at the same time. During the test execution, it will collect key performance indicators such as latency, error rates, as well as tests per second on the background. It will also capture Windows performance counter and Tableau Server internal JMX counters so that you could perform analysis afterward. Within Tableau, we are facing challenges similar to you guys. In fact, TabJolt was created in an attempt to solve our in-house load testing challenges against Tableau Public. Tableau Public is a free-to-use environment by everyone to publish workbook and share them with the rest of the world. As you have seen yesterday in the keynotes, there were 1 million today workbooks in Tableau Public. So that's actually creating a huge challenges to our internal engineering team, because we are spending a lot of time by using the traditional load testing approach, such as record and playback, to create the load testing scripts for each of the workbook. To make things worse, every day, people are updating or publishing new workbooks to Tableau Public. It became a maintenance nightmare for us to catch up with the change. So we were thinking really hard about whether we could create a robot-like tool so that it could load any random workbook, understand its contents, and perform interaction accordingly based on its contents. This was how TabJolt was born It was an effort to solve our internal challenges. Who is using TabJolt? Within Tableau, the engineering team is using TabJolt every day to conduct performance as well as stress tests, to measure performance improvement, as well as guiding product regressions. We also use TabJolt to conduct scalability tests, and we have published scalability white paper as a result of that. And our in-house professional service team will go to the customer sites and troubleshoot their performance issues by using TabJolt. Outside of Tableau, different customer is using TabJolt for different purpose. For example, one of the leading credit card provider in the North America is using TabJolt to validate their production environment readiness. And one of the leaders in human resource solution is using TabJolt to determine additional capacity after they purchase more CPU cores from us. And one of the leaders in semiconductor industry is using TabJolt to determine whether or not their backgrounder can finish on time and successfully. The list just keeps going on. So without further ado, I'm going to have my colleague Wavi to showcase the first demo.
So Kaifang just claimed that TabJolt is easy to use. You don't need any prior scripting or coding experience. So basically, I have one job today to prove that my boss is right. No pressure. So you can go to Google and search for GitHub TabJolt. So we uploaded our bits there. So I already downloaded the installer here onto one of my machines. So I already installed on this machine before. By default, it will install to C, TabJolt. And TabJolt has 3 dependencies. It has dependency on Java, Apache JMeter, and PostgreSQL. Our installer will take care of everything for you, copying the JRE bits and taking care of Apache JMeter. And we also install PGSQL. We have some schema files that we install as part of this, and we run those schema files and create the tables. So when we do our perf testing, results go to those tables, and we can use the Tableau to look at those results. Now it's installing. Okay, now we're done with the installation. Now we are on to configuration part. So here it says Tableau Server information. First thing we need to give our Tableau Server URL. So I already have my server set up. By the way, this is Tableau Server admin credentials, not your Windows Server admin credentials. For example, we do validation here. Let's say we give something wrong, either username, password, or the server name. It's gonna say I can't log in. Click next. All right, now what it did is it logged into Tableau Server and goes to Viz portal, or the page where you see your workbooks, views, etc. By default, it will get the top 5 views. If you go to your views page, you can see which views are more popular. You can click on the views page, right? You can see that which view is being viewed more. So by default, it will get top 5. And it will do validation here as well. In fact, if you want to delete some of these, you can do that. Or if you want to add something here, you can do that too. In fact, let's say if you add something like this and say next, it says that I can't access that view, so please check the URL. So I'm gonna fix this. Click next. So finally, we are on to collecting server performance counters. So here, it's asking whether the current logged in user has Windows Server administration credentials on the remote machines. So for example, you can go here and say, who am I? In this case, I'm a domain account named TSI DevAuto. So as long as that account has Windows Server administration credentials on your primary and workers, you are good to go. Otherwise, you can give a different account here. In my case, since it's the same account, I'll just leave it as is. And one more thing here. When we give server admin credentials in this screen, TabJolt figures out your topology. So someone might have one primary, one worker. Someone might have one primary, like 5 workers. It figures out how many vSQL servers you might have on your primary versus worker. How many backgrounders do you have? And underneath the covers, it populates your config files so that it can fetch all the server JMX counters automatically. So you don't need to worry about any of that stuff.
Oh, we are going to leave the we have 15 minutes at the end for Q&A, so we are going to leave the question at the very end. Thank you.
Okay. So say finish. So as you can see, installation is fairly straightforward. Now let's see how easy it is to run a test. Okay. Running a test is as simple as, go. Okay, let me point to a few things here before I kick off the test. So this is our installation folder. Here we can look at test plans. In the test plans, we have 3 default test plans that we installed here. One is called view visload, another one is called interact visload, another one is called view and interact. View visload by default only loads the views and it just keeps doing in a loop. Let's say you specify 10 views that you want to test against. And you specify, say, I want 10 users or 100 users. I want to keep loading these views. It loads them, records the perf counters, records how long it took, and it keeps doing in a loop for whatever the time you specified. And this interact visload, it does similarly, but the only difference being it not only loads the view, it interacts with your viz as well. So I'm going to run this test. So say I'm going to point to my test plans. Okay. And then next thing is how many threads I want to run on my Injector machine. So one thing to note here is we recommend you run this tool not on your Tableau server so that, this load doesn't interact with your Tableau server. And we recommend that you keep it on the same network so that other factors doesn't come into play. That way you have a good shot of measuring your server performance. So next step is here. I'm going to specify like 5 threads or 5 virtual users. And D is duration. This is in seconds. I'm going to specify 5 minutes or 300 seconds. And finally, this is some description field. You can write anything here. My case, hope, demo gods are smiling. Something like that. I click go. So a few things to note here. So it will keep, so let's pay attention to a couple of things. One thing is, it says run ID is 14. You need this to view results. We will display this at the end as well. This is one thing to note, and I'll let this go. Here, it shows that we are running 5 threads and how many samples it's collecting. You can ignore this latency. This is coming from Apache JMeter. And finally, response time. This response time is in milliseconds. So this includes the time to log into your Wiz portal, load the view, and interact with the view. And finally, errors. If you see errors here, in my case, I don't have any errors in this run. For example, you might have some errors in your run. So that's one thing you need to pay attention to. If there are any errors or high count of errors, you might want to see what's going on. I can show you a demo of like, if there were errors in my run, how can I go and take a look at those things? So, or if you see a response time being too high, that's something that you need to pay attention to. I'll let this run in the background. I'm gonna give control back to Link. And once we come back, we'll take a look at the results. By the time run would have been finished.
Thank you so much, Ravi.
Thanks.
So one thing I would like to add is we have a very good documentation for all those like parameters in the execution. So you guys could actually refer to the installation guide and see like what does each of the parameter means. So I'm going to talk about some of the common Tableau Server administrators challenges and how you could use TabJolt to solve them. When you purchase Tableau Server, you get the recommendation from our sales team. And it's based on our internal data and experiments. Once you install Tableau Server, you get the out-of-the-box configuration. Now you could use TabJolt to simulate the kind of traffic you are expecting for your organization and make sure you have purchased enough CPU cores for your organizations. It's a huge moment to take your Tableau Server online. You want to make sure everything goes smoothly. Before you take the server online, there's a unique opportunity for you to use your production environment as testbed. You could use TabJolt to generate the kind of traffic you are expecting for your production and make sure your production environment is ready for the prime time. There were a lot of factors you need to consider when you are doing a server configuration. For example, you need to decide what's the hardware configuration specification for your servers. And after that, you need to decide how to deploy the Tableau Server components. For example, how many workers do you need? And on each worker, how many rescale process and background process you need? Basically, you could use TabJolt to experiment with different server configuration and find out the best one which can fit your organization's requirement. As the user activity increases, you may find out the once responsive server becomes slower. You could use TabJolt to generate large enough traffic to reproduce the performance bottleneck and perform troubleshooting. Nowadays, more and more enterprise is using VM to host their Tableau server. There are many knobs in the VM setting you could tweak. For example, CPU affinity as well as memory allocation. You could use TabJolt to experiment with different VM settings and find out the best one for your organizations. If you are a server administrator, chances are you'll be questioned by your upper management for whether or not your Tableau Server deployment can fulfill your organization's requirement, as well as providing delightful end-user experience. This is a very difficult question because the answer can vary based on the complexity of the workbook, the background activity, the hardware which is hosting Tableau Server, as well as the end-user activity against Tableau Server. Tableau Server will perform differently based on the actual user traffic in your organization. You want to use TabJolt to make sure you have purchased enough core and workers for your organization to support the user traffic. I'm going to hand back the stage to Ravi.
All right, let's take a look at the results right now. So here, at the end, it says that we're done, we're tidying up, and it shows that use this run ID to look at the results. Now, this is our install folder. So by default, we put this workbook there with some pre-built dashboards. So we go to the workbook. For some reason, it's showing Windows in Windows. Maybe I should just close and reconnect again. Let me do that, see if that helps.
Was that Postgres? That was your Postgres
Yes.
database login?
Right. So, yeah, we documented everything, all the passwords and everything. So now we use this Tableau workbook that we pre-built for you, and we connect to the Postgres that we installed when we installed TabJolt. So the run ID in our case was 14. So I practiced 13 times so far, by the way. That's what it's showing. All right, let's take a look at that. So a couple of things to note here. So by default, it shows like what time our test started, what time our test ended, and if there are any errors during the run, that's what this shows, and what is the average response time for the views that we are testing against, and similarly, how many tests per minute that we are running here. So this is the graph. So this gives at a snapshot view at the higher level, like how many threads or virtual users that we ran with, and what is the average throughput, what is the 90th percentile, 95th percentile, and for 90th percentile for success responses versus for all the responses. So this is the starting dashboard. It will give you a pretty good idea of how your run went, how your server behaved, etc. Now, let's drill down a little bit more into it. So if I have any test errors, so there were other dashboards that we can look at. I'll come back and show you those as well. So once we go to this dashboard, right now there is a small bug in it. We're going to fix it. It shows all the tests in this test failure details because our filter is not applied properly. Here, one thing you can look here is it shows like by workbook how many times we finished the tests. So if you look in the starting dashboard, this is the total number of samples that we have, and here it shows by workbook. This is the workbook name, this is the view name, how many times we loaded these things. Now, let's look at the scatter plot. So if I say that, show me all the responses on a scatter plot, let's say I want to take a look at WishPortal user login. So these are all the WishPortal user logins. So from this graph, we can tell that vast majority of our WishPortal logins are under 150 milliseconds, right? Sorry? Yeah. We can update these dashboards as well. So yeah, these are all like starting dashboards. We have few more dashboards that I will show you, and this data is available on your local Postgres that we installed. You can always go to data source, right, and see how we are connecting to. You can pretty much connect to the same one and take a look at what tables we have. And you can I'm sure you can build better dashboards than us. So next, let's take a look at more interesting one, CPU and memory. So in this case, this one was 14. So in my case, so the local host is where I ran my test, in this case, which happened to be the Injector. We call it as Injector. So make sure that whenever you do test, let's say you're running a test with 1,000 threads or 500 threads. Make sure this machine is not saturated. Otherwise, that might be the bottleneck. So pay attention to the CPU usage and memory usage on the machine where you are running the test. And here, in my server topology, I have two machines, one primary and one worker. This is primary and this is worker. They are pretty much, they are identical actually, except the DB. So here, we show the CPU usage at system level. And similarly, this is memory usage at system level. So you can see other counters that we are collecting, these Windows counters. And we have other dashboards where you can drill down. For example, we have a dashboard just for WSQL, where you can take a look at JMX counters. You can take a look, see how many sessions are in flight, etc. Yeah, one thing, for us to collect JMX metrics, you need to have JMX enabled on your servers. That's one thing to note. And yeah, this is, let me switch back to another demo of, let's say you're trying to do some capacity planning. Let's say you're trying to say these are the goals. Our goal is to figure out how many workers do I need to have so that my Tableau server can scale up to, say, 1,000 users per minute, both views and interacts in this case. And we're trying to figure out how much CPU do I need, how much memory do I need. And I'm trying to, say, figure out what kind of configuration should I have so that my end users will have good, decent experience. So we ran some tests to figure out how, using TabJolt, we tried to figure out how we can do capacity planning for this exercise. So for this exercise, we kept adding more workers one at a time. Let's see how it performed. So these are the results from one worker case, where if you pay attention to tests per minute, it roughly about 300 per minute. In our case, we need close to 1,000 per minute. So clearly, this is not going to cut it, right? And let's look at resource usage here as well on one worker case. As you can see, CPU is about close to 80. We definitely don't want to run our CPU to be too hot. Like if it is, say, on an averaging 90+% all the time, it's definitely not good. At the same time, we don't want it to be underutilized as well. We want to make sure we get good value for the hardware that we have and make sure that it's performing well, right? Let's take a look at two-worker case. So here, this light blue is the two-worker case. And as you can see, now we are close to about 600 tests per minute, whereas one worker was about 300. We are still not close to our goal of 1,000 tests per minute. And if we look at average response time, they pretty much are going hand in hand. And at the same time, error rate is also staying close to 0, except in the first case where there was a spike in the middle. And let's look at resources on, resource usage on two-worker case. So here, similar to our previous case, average is about 80%. But still, we are not close to our goal of, say, 1,000 tests per minute. So let me switch to three-worker case. Three-worker case is the orange bar. Now we are pretty close to 1,000. At the same time, our error rate is still down. It's not much. And our average response time is still tracking with the previous runs. And let's look at the resource usage in this case. It's still good. It's only 73 to, on an average, about 75% in this case. So let's see what happens when we add one more worker to this case. So the top bar that you see is the one with 4 workers. So now we shot up to 1200 per minute. So clearly at this point, we are over provisioned for our usage, for our test case rather. So in this case, the conclusion is that for our use case, we are good to go with 3-worker case. We don't need to add the 4th worker. We are a bit over provisioned at that point. No, for our needs, we could save some licensing costs to hardware costs, things like that. That's about my capacity planning demo. Let me switch back to Kaifang.
All right, thank you, Ivory. So let's continue with the server administrator's challenges. As your organization continues to grow, you will have to support more users in your Tableau server. And the existing user will continue to publish more workbooks to your server and become more engaged with the server. Now you will want to use TabJolt to generate the load which we present in the future and reconfigure the server if necessary. Your organization may want to upgrade to the latest Tableau version to take advantage of some of the new features. You want to use TabJolt to make sure the existing user experience does not degrade in the newer version with the existing user load. And also, you want to make sure the newer feature is able to provide delightful end-user experience by using TabJolt to generate the future user load. So let's dig into how TabJolt works internally. Basically, when we try to design and implement TabJolt, there were a few principles we have kept in mind. First, we want to leverage the existing Java test functional library as much as possible. Secondly, we don't want to reintroduce a new performance tool because we know we could introduce performance bug in the new tools. So we pick JMeter as the underlying load generation framework for the following reasons. First, it's widely adopted in the industry. Secondly, it supports coded Java tests. Finally, and most importantly, it's free to use so that we could share TabJolt with all of you guys. We then build business logic module on top of JMeter by simulating end-user activity, by sending the HTTP request to the Tableau Server gateway here. And then the server will send back the response back to TabJolt. TabJolt will process the response and save the results to the PostgreSDB so that later on, you could use Tableau Desktop to analyze the results. Now, Wavi is going to showcase the last demo.
Yeah, let's take a look at one final piece here. Come on, escape button. Come on there. There. Don't save. All right. So this is our installation folder. Let me show you a few things around here. So if you go to the config folder, you can see all the config files that we are using. So the first one is when we did our configuration, it asked it by default, it populated 5 views. So this is the file it writes to. So you can edit this file and just save it and rerun your tests. Okay? And also, we gave only one Tableau Server administrator credentials. So that's the user it's using to log in and load the views. Let's say you have a test environment with hundreds of test accounts. So this is the file you can populate with those test accounts. And we'll use them in a round-robin fashion. Okay? Now, let's take a look at another one. So here it says that use this file, userpool.csv, and clearly it says that, use vispool.csv. And another one is, by default, there is no think time between the tests. Whenever it loads the view, interacts with the views, it just keeps doing in a loop. If you want to say add some think time, so this is where you go and change it. Let's say you want to add some 5 seconds think time in between each loads. So you can try that out here. And there is one more knob here, which says that, let's say, after loading the view, we interact with the view. Let's say you want to add some think time there. So this is the knob for it. And finally, there is one knob that says that if there are too many errors in my run, don't keep running the test. Quit the test. There is no point in running anymore. So this is the knob to try that out. You can say that, if there are more than 100 errors or 1,000 errors, don't run my tests anymore. And let's take a look at a few more things. So in the test plans, so these are the 3 default test plans that we installed. We also installed something called some customized or advanced test plans here. So the way you look at those test plans is, you basically start JMeter. So JMeter is installed in the bin folder. You start bin, JMeter. So this is the JMeter UI. So what you are looking at here is, pay attention to this graph. Basically what it's saying is, start my test with 40 threads and keep adding 5 threads, keep stepping up my load for every this many seconds. So let's say if you want to add 10, you can see how it changes basically. Or if you want to just add 2 for every other interval, you can see pictorially or graphically how the load changes. And there are other variables that says that how long do you want to run this test to, what the ramp up is. You can use the ramp up, or you can say how many seconds do you want to hold this load for. There are a lot of parameters that you can tweak and test load against your server. So this is just one of the test plans. There are 2 more. I'm not going to save anything. So there is 2 more test plans here. You can open them in JMeter and take a look at this. These are all standard step-up patterns that a lot of people use in general for load testing. So these are some of the advanced use cases. And I'm going to give control back to Kaifang.
So as you have heard in the keynote, Tableau Server will be available in Linux fairly soon. So in the upcoming release for TabJolt, we are going to support Tableau Server in Linux. Let's recap what we have talked today. First, we talk about some of the common Tableau Server administrators challenges and how you could use TabJolt to solve them. Then Ravi showcased the first demo for how easy it is to install, execute, and perform analysis by using TabJolt. Then he walked through a case study by using TabJolt to conduct capacity planning. The last demo he has is to tweak the default configuration of TabJolt to meet your specific needs. Finally, I would like to share some of the best practice of performance testing we have here in Tableau. We have a culture of high performance, which means we conduct our performance tests early and often. By doing our perf tests early, we could spot the performance bottleneck early in the development lifecycle so that the feature team can easily refactor the feature. By doing the perf tests often, we could track the performance regression or performance improvement to a specific check-in. In addition to the multi-user load, we also have perf test for single user load, which measure the end-to-end user time in browser or desktop. There were a few other talks in TC to talk about the other performance testing tool we have, such as Tabman, Logshark, Scout, on replay. I've attached a list of the list of sessions in the appendix of this slide decks. So you could, if you are interested, you could go to those sessions too. We have different test suites for different features and functionalities. And finally, we conduct our tests in many iterations. And we look at the performance results and make sure we rule out the performance noise. Performance noise can be created by the test environments, such as network or Windows upgrade. We want to make sure we file product issues instead of one-off environmental issues. So that's it for our sessions. We are open up for Q&A. Go.
So you mentioned that whenever we're running TabJolt, you want them to be on the same network. You know, obviously we have a user's VLAN and a server VLAN, et cetera, et cetera. Wouldn't testing it off of the user side going to the server's VLAN, wouldn't that simulate, you know, ore to shore, so to speak, much better than throwing them on the server's VLAN and testing that way?
So let me repeat the questions. So basically, the question is whether it's better to put the injector. The injector means like the box where you install TabJolt on a different network than the server, so that it can better to represent the user experience, end-to-end user experience. So you could do that, but I mean, the recommendation here is like, remember, our goal is to try to figure out the limit of the server. If you actually put TabJolt on a different network, then basically, like, you are not actually testing the full capacity of the server, because there's certain delay or latency when TabJolt actually send a request from this network to that network. So that will actually, you won't be able to actually test the full potential of the server. While if you put TabJolt on the same network as the server, so basically the latency is close to zero, then you can hit the server as hard as possible. So if you want to, so typically what we have done in the perf team within Tableau, we use TabJolt to generate a load on the background. That basically simulates thousands of users hitting your server at the same time. And then we use some other single user load testing tool, such as Scout, to actually run it on the network, which is different from the server, so that you could actually measure the true end-to-end. Because like, if the server is not under load, like let's say the server has just a couple users hitting it, you will never know like what's going to happen when the server is under load. So you want to use TabJolt to simulate that kind of load you are expecting to see in the production. And then you could actually use Scout on a different network. Like, let's say you are a multinational company, and some user actually try to browse to the server in other location, like Germany or something like that. Then you can actually run Scout on those locations and measure the end-to-end user performance. Or you can even like manually open up the browser when the load test one is on the background, and then see like, wow, how does it feel as an end user when there are thousands of other users hitting the server? Right. Yeah. So basically, that's our recommendation. Yeah. Go ahead.
So how do you test the extract? You're talking about everything in the view and dashboard. How do you test the extract in the service manual?
So let me repeat the questions. The question is how we could use TabJolt to test extract. I will leave the question to Ravi, because he has done that.
Yeah, by default, we didn't provide the test plan here, although we do have some test plans that we use inside Tableau to test extract times, to try background or capacity. We can potentially look at, probably as part of next release, maybe provide an extra test plan to do that. That's one thing potentially we could do.
So even before that, what you could do here is like, so typically, so for example, the example I gave, like the leader in the semiconductor industry, the way they have done that to make sure that backgrounder can finish on time and successfully is they actually generate a load. So backgrounder basically, it really depends on the organization. Like for some of the organization, the backgrounder job is actually running 7/24. Like just keep running all the times. So what you could do is like because like when the backgrounder is running, and then the user is hitting the server, there will be certain interference. You want to make sure when the backgrounder run, the user is not impacting. And then the backgrounder time is not actually like exaggerated or something like that. So what you could do is like you can keep TabJolt running on the background for a few days, as long as you want, anytime, as long as your machine is up. And then you could actually schedule your backgrounder running on the background. And then what you could do is like you could look at the log, and like the backgrounder log, and see how long the backgrounder actually finish. So that's how you actually measure the end-to-end time for backgrounder. And then from an end-user perspective, you could just open up the perf results, and then it's going to show you like within the last, like let's say you run the test for 72 hours, how the user experience is looking like all the time. Does it actually spike? Does it actually go down? And something like that. So, I mean, coordinate that time with the time your backgrounder is running. Then you can figure out when your backgrounder run, how the user experience is going to be impacted. So I'm going to take like from this direction.
So is there a way to automate this load test? Automate in the sense like run it like every day and maybe send out an alert if there is if it is taking more than a human threshold. Do you guys do it? Or is it all manual as Ravi was looking at the apps?
So the question is whether we could automate TabJolt so that it can run every day and then send out alerts if certain threshold is violated. For example, like if the response time is taking too long or something like that. So let me put it this way. You could automate TabJolt running every day. Basically, you just need to have a scheduled job in Windows or whatever operating system you have. And then like schedule run every day. Basically, you just schedule that particular script Ravi has shown on the demo. That will keep TabJolt running every day. But at the current moment, we don't have alerting features. So if it actually violates certain threshold, it won't actually give you email alerts or something like that. You may have to extend it yourself because all the results is being saved to PostgreSDB. So basically, all you need to do is just like look at the response time in the PostgreSDB. Like we have a table called like test run table, and then it gives you, so the summary on the perf results dashboard, basically it's from that table. The table tells you 95 percentile, 90 percentile, like the user time. You can just like do something yourself. But at the moment, we are not supporting that yet.
You could just publish the generated workbook, though, and add a subscription at yeah, and then just have it emailed to you.
Yeah, you can do that. So there is a new feature in, I believe, 10.4. It's something called data-driven alerts. You can modify the dashboard to have the bar charts. You can say that as long as it exceeds certain threshold, send out an email. Yeah. 10.3.
10.3.
Okay. Thanks.
There you go.
See.
That's awesome. Yeah, go ahead.
So quick question is, since you have thousands of sites in Tableau Server, so when you do every site, every view, configuration file.
So the question is like, what if you have 1,000 sites of thousands views? Do you need to actually put all the views or sites into that vispool configuration files? So TabJolt, it has two modes. One is called vispool mode. So basically, you specify the vis you want to hit on the vispool. And then the second mode is called caller mode. Caller mode basically will automatically figure out what are the sites and workbooks in your Tableau server. And it will randomly load those workbooks. instead of the one you have specified. You just go to all the available workbooks in the server and randomly load each one of them. In fact, that's how we actually do performance testing against Tableau Public in-house.
With the introduction of the Hyper engine in 10.5, do you recommend that we look at our current architectures for locally hosted Tableau Server? So should we stand that up against TabJolt to make sure that our configurations are correct?
That's a very good question. So the question is like, with the introduction of Hyper and other new features in the coming release 10.5, should you guys be using TabJolt to validate your server configuration is good enough to support the newer version? I would say yes, because like, as I've talked, that's one of the very common server administrators' challenges. Like when you actually upgrade to a newer version, you could always use TabJolt to make sure whether your existing user workload like can be supported in the newer version and the user experience does not degrade.
Yeah, let's take one from this side.
Yeah,
and then
sure.
We'll keep going.
Is there any general guidance about the number of workers versus the machine size in Injector? Like, say, I've got 4 cores on it, I should only use 4 workers or 8 workers. And related note, is there a way to monitor within this tool the performance characteristics or curriculum of the Injector so I can tell that it's not being throttled, it's not causing a bottleneck in memory, processor, I/O, or network?
Okay, so let's take it one at a time. So let me repeat the questions. The first question is like, is there any recommendation we have for how many workers you should have, and on each workers, how many CPU cores you should have?
Or what's the limit for, if I've got a box of X core, how many workers can I go up to before that becomes a limiting factor?
Right. So I will leave the question to Ravi because he has done very extensive work for our Scalability white paper. And then, yeah, so basically he's the person behind the Scalability white paper. And that exactly will answer your questions.
So we usually start with, say 8 core, right? Say start with 1 primary and add 1 worker. See how much it scales up to. Let's say if it is good enough for your use case, you stop there. As we saw in the capacity planning demo, we keep adding 1 worker at a time and keep redoing our perf testing to see how much it scales up to. Basically, we test the scale out.
So I'm asking about the Injector. I'm curious about when the Injector, if there's any guidance there, when it will become the limit.
Okay, so one of the dashboards, it shows metrics for both Injector and the servers. So every run, you should look at Injector as well. See if there's if Injector is hitting the limits, right? You don't want the bottleneck to be on your scripting side or where we are running test side. So it shows you what the CPU usage is, what the memory usage is. So if they are looking good, then you are good on the Injector side. If they are getting overloaded on the Injector side, you definitely should look at upping the number of cores on the Injector so that when you say if you add 500 threads or 1,000 threads, it can actually do the work on the.
Is there a possibility running into a bottleneck with the I/O, say to the monitoring database or to the network?
Possible, definitely. So we have a mode to support multiple injectors as well if needed to be. But most of the times with our testing, we could just
this is the WISP Ravi is talking about. And in general, the requirement for Injector is really, really low. So you could even use a desktop because there's certain smart thing we have done on the Injector, for example, like caching. Like we actually cache certain, the top workbooks being used by the Injector, TabJolt, and cache the results. So, so that we are able to actually, we want to make sure TabJolt itself is spending as little time as possible so that we are measuring the actual response time from the server instead of the time being processed by TabJolt. So in general, the hardware requirement for TabJolt is really low. Like you could actually have a 4-core machine with like 4 gig, 8 gig, whatever you want, and then it will just work. But I mean, like as a best practice of perf test, you should always look at the resource consumption on your injector and make sure it doesn't become a bottleneck. But generally speaking, like we have never seen like that become a bottleneck. But I mean, just in case you do use a laptop or you have some other antivirus running, like as I've mentioned, there are other performance noise, like in the perf test. Like so, for example, when some people actually running TabJolt, he see inconsistent results. Like I actually receive quite a lot of questions for that. Like you should look at like when you're actually running TabJolt, are there any other like background software actually running? Like is your Windows update actually, like that actually happens a lot, the Windows update. So that actually interfere with the test results. So typically what we do is like we actually do the test many times, like 10, because the larger the sample set you have, the more confident you are going to have. Like basically that's a statistic things, so yeah. Yep.
Oh, sorry, we'll go to alternate. Yeah.
Sort of following up on that, and I'm with Robbie, I want my boss to be right. My boss told everybody that I would come back from this expensive conference with ideas about moving to the cloud.
Okay.
Is it possible to set up just TabJolt on the cloud for on-prem servers, and is it possible to have TabJolt on an AWS server hitting AWS and are there any changes in how you configure it?
AWS to AWS should be doable, but from your on-prem to cloud or cloud to on-prem, we will have trouble collecting perf counters. As long as it can see the Windows machine or Linux machine for that matter in the next upcoming release, as long as they can talk to those machines within the same network, we can collect all the counters. But you can't cross like on-prem to cloud and vice versa. Okay, sorry. Okay. Well,
Talk a little bit about how the interact tests work. Few tests I get. The interact, I've got some dashboards that my users typically do sorting on, and other ones they typically change date ranges on using parameters. So how does the interact, what is it actually doing?
So the question is like, what exactly the interaction is doing in TabJolt? So currently, TabJolt support quite a few of interactions, but it's not doing all the interactions. So by default, it's actually follows certain priority. So first, it will actually do filters or parameters and those type of things. If it cannot find any interaction, at the end, it will just do random selection of the marks. So like there's about like 10 interactions TabJolt is capable of doing currently. So basically, it will just check whether or not your dashboard support those interactions and randomly pick one of the interaction from the list.
Is there any way to control that?
So currently, we are not exposing that. There's a way to actually change it in YAML file. Like internally, we are doing that, but we are not exposing that, and we are not recommending you actually change the YAML file because it's fairly complicated. Yeah, so we are not exposing that externally yet.
So one will take from here.
Is there any really good best practices for dealing with the fact that your test user is going to have 100,000 hits to Tableau? Like, is there a good way to deal with that back end so you don't have to?
Or you are running against production.
You're running against production, so it's not affecting the rest of the.
Repeat the questions.
Yeah, his question is that if you are running your test against the production itself, and let's say you have test users, and is there any best practice that you can say, you know, your test users are going to show up, or whatever they are loading, those views are going to show up at the top of the list everywhere. I'm not sure, actually.
So
I generally stick to the staging separately versus production.
Yeah, so remember, you can actually provide the user pool, the user pool files. Basically, so that can actually distinguish your test traffic from the other real user traffic. So for example, if you look at in the admin page, the status page, there are different views, right? You can actually see the traffic. You can actually filter out traffic by the users, right? So that's one way you can actually tell whether or not But I mean, right. But you can actually supply a different credential, not credential, Tableau Server user account, and then use that as the test account. And then so when you actually look at the traffic, everything sent by that user is the test traffic. Or you could actually have multiple test accounts for that purpose.
It still messes up, say, things like, for example, if you go to the views, right? Whatever the views that you are loading, those.
So
will
you
be
have to
top
filter
views,
out.
right?
You
So
have to
few
filter
things,
out
so
that particular users.
things, right.
And also, you have to be very careful when you're actually running the test against your production environment, because you don't want to generate too much load to actually tank your server, so that the real user cannot actually have very good experience.
So let me add just one point. So there is a different tool called Scout, so which basically runs in single user mode. That is probably a good tool to run against your production than something like TabJolt, since it only simulates one user. So you can measure, say, if you want to measure your server perf during middle peak of the day, you can run the tool, you can see how your real users are perceiving, how the end user experience is against your own production. There is a Scout. I can look up the session time and date.
Actually, I have the list here.
Okay. Okay.
1 second.
PowerPoint there.
Yeah. So basically, that's a single user page load test too, and then
So
it will give you idea how the end-to-end user experience it is.
Over there at the back. So. It's a open source. It's on GitHub. No, it's just a free.
It's community support.
Yeah, it's a community supported tool. So.
If you're running in production, is it valid to schedule that for an off-hours test, and you'll still get some decent results, even though you're not simulating live?
That's another approach you could take.
Right.
Yeah, so there are a few approaches you could do with production. Yeah.
Yeah.
Yep.
Okay.
Thanks. These slides. So after the conference, basically, I believe you guys will have an email, tell you where's the recording of the session it is. Then you could actually go to that link and find out our sessions and get the recordings.
So it's like audio recording with the slides in the background. I believe that's what you're gonna get. So, well.
When you use the simulations for the views and/or interactors, does all that get logged in the history in the Postgres repository, so it looks like there
Yep.
were...
Yes.
Yes. Yep.
Yes.
We actually log everything.
Yeah.
Right, so that would affect the ranking of those popular databases.
Yeah. Definitely.
Yep.
Definitely.
Yep.
That's one thing to keep in mind. Yeah. Well, thanks for coming, everyone.
Thank you.
Yeah.